Non-repudiation. To repudiate means to deny. Non-repudiation is the assurance that someone cannot deny something. For example, Mr. X buys a cell phone for $1,000 and writes a paper check as payment, and signs the check with a pen. Later, he finds that he can't afford it, and claims that the check is a forgery. Unfortunately, the signature guarantees that only Mr. X could have signed the check, and so Mr. X's bank must pay the check. This is non-repudiation. Mr. X cannot repudiate the check. Pen and paper signatures aren't hard to forge, but digital signatures can be very hard to break. For example, you might send registered mail, so the recipient cannot deny that a letter was delivered. A legal document typically requires witnesses to signing so that the person who signs cannot deny having done so. In cryptography, non-repudiation means a document can be digitally signed and validated with a specified set of steps. After this process, both parties are sure the other can't deny that they signed the doc. Non-repudiation is accomplished by the originator signing the message using a private key known only to the originator, and which the originator commits to protecting. Protecting a private signing key means keeping it confidential and, if the key is compromised, promptly revoking the matching public key. Risk to non-repudiation is disclosure of the originator's private key. If the private key can be obtained by an attacker, then he can sign any message. To ensure digital signatures retain non-repudiation even after the compromise of the private key, one can use a trusted timestamp. Timestamp is an audit trail that provides the information on the time when the message was sent. Weaknesses in the public key infrastructure, PKI, which lead to recipients of the message being fooled into thinking a certain public key is associated with a certain entity. When attacker generated the public key and managed to spoof the identity. Another approach to non-repudiation is to use a blockchain. Blockchain is a form of a distributed ledger in which records are recorded and linked together, using cryptographic hashes, meaning that to change any record in the blockchain, one must change every subsequent block. Blockchain requires the collusion of a majority of the blockchain participants. For a sufficiently widely operated blockchain, this is infeasible. For example, Bitcoin currently has approximately 12,000 nodes across 100 countries.